Okay, so today we're just going to continue just practicing graphing these trig functions, and then we're going to also generalize a few formulas to kind of work on some of the different parts. The four main parts that we're looking at are our vertical shift to get our middle, vertical middle, our phase shift to get the start point, the horizontal shift, the period to get the end point, and the amplitude to be able to go up and down from the middle to the top and top to middle, etc. Okay, for each quadrant. So when we look at this, we need to kind of think, what are the four main parts? Okay, so what is our vertical shift here? We look on the outside, our vertical shift is +1. We need to know what the period is. When we want to know the period, we look at the horizontal expansion compression factor. This is a sine graph. It's usually 2 pi. It's been compressed by 2 and flipped horizontally. Okay, so we'll deal with that flip horizontally later because we don't need to worry about direction yet when we're talking about the period. So it's going to be 2 pi over b, which is 2, is equal to pi. So that's our period is pi. Our horizontal shift, which is our phase shift, is going to be to the right, pi over 4. Okay, and then the amplitude of this function, the amplitude is generated by looking at that leading coefficient. Okay, so in this case, the amplitude is 1. Okay, so how does this horizontal flip affect the graph? Well, there's two ways we can look at it. So one way is, well, we can say that normally we graph the sine graph in this direction. Okay, it looks like that. But we could also maybe think of it as a horizontal flip, graphing in this direction, and graph it like that. Okay, so that's one way we can think of it. The other way we could think of it, instead of graphing it from right to left, we could graph it from left to right. And if we graph it left to right, and again, if I graph it left to right in green here, notice it's just a vertical flip. Okay, that is actually just a vertical flip of the original sine graph. So there's two ways we can treat this. We can treat a horizontal flip of sine as a vertical flip of sine. Okay, for now I'm just going to graph it from right to left, thinking of it as a horizontal flip, and everything now is going backwards. Instead of right to left, left to right, we're going right to left. Okay, so where's my horizontal flip? The shift is going to be to the right, pi over 4. So I'm going to put my x-axis here, sorry, my y-axis here, and I'm going to say my horizontal shift is to the right, pi over 4. So there's my starting position. Okay, I know I'm going to go in this direction. Okay, and I need to go pi in that direction. So that's a quarter pi, half pi, 3/4 pi. There's my full pi. Gets me to the end point. I need to locate the coordinate of that. So that's going to be -3 pi over 4. Okay, once I get that, I'm going to draw in my quadrants. Okay, the middle, halfway between -3/4 and 1/4 is -1/4. Halfway between here is going to be -1/2. Okay, and there's my quadrants. I've got all four quadrants kind of laid out now. My vertical shift is +1, and my amplitude is 1. So I'm going to draw my +1 about here. Y equals 1. And then I'm going to go up to 2 and down to 0. So I've accounted for my horizontal shift, my period, my vertical shift. Now I'm going to use the amplitude to sketch this graph. So I'm going to start, that's my starting point, and then I'm going to go backwards. I'm going to graph in this direction. So I'm going to go up to the max, to the middle, to the min, back to the middle. Okay, so my graph is going to look like this. Those are my four quadrants. Okay, so that's one way to do it. And the other way to do it is, and I would have probably chosen a different location for my y-axis, but notice that if I had gone from started at this point here at pi over 4, if I continue this graph, notice that would be going in this direction here. And essentially that would be graphing the same sine function, but instead of graphing it as a regular sine function like that, it's a vertical flip of the original sine function. So there's two options here. Okay, I showed you the first one where we just looked at it as a horizontal flip going from right to left. But those are actually equivalent, and we'll talk about that a little bit more later. But that's an equivalent to a vertical flip, okay, going this way. Again, I need to make sure I label my max and min coordinates. Okay, my max coordinate here is at 0, 2. My minimum coordinates at negative pi over 2, 0. Okay, those are my max and min coordinates. I could also find my middle points, which are, again, my reference points. Okay, this graph here. Now, I talked about in the last class was that if we want to know the true horizontal shift or the true phase shift, we need to put this into factored form. So that's the very first thing I'm going to do. I'm going to rewrite this equation, this function, in its factored form. I'm going to factor the 2/3 out. Okay, when I factor the 2/3 out, it's going to be plus 3 pi over 2. Okay, minus 1. Again, but if I'm factoring, I need to divide by that factor. So when I multiply back, notice I'm going to get the 1 pi there. Okay, just going to move it over a bit so that I can see it a little bit more clearly. Okay, maybe I'll move it over here. There it is. Okay, so that's the graph, that's the function I'm going to use. So from there I can establish my vertical shift, -1. My phase shift is now in its factored form, so I can use that. It's going in the opposite direction, 3 pi over 2. The period, in this case, is going to be the horizontal compression. So it's going to be 2 pi it's horizontal expansion in this case, divided by 2/3, which is 3 pi. So that's my period. The amplitude is going to be 3. And please don't say it's -3 because the amplitude has no direction. Okay, same with the period. Period does not have direction. Okay, so I'm going to establish my points here. The period is 3 pi. My shift is 1.5 pi. So I'm going to maybe put my x-axis here, or my y-axis here. Go negative pi is here. This is -3 pi over 2. Okay, so there's my starting position. I'm going to go 3 pi over 2 in the positive. Okay, so that gives me my period from here to here represents 3 pi. And then I'm going to split up my parts here, and it's going to give me my 4 quadrants. So I have my 4 quadrants. There's my 4 quadrants here. Okay, the vertical shift is going to go down 1, and the amplitude was 3. So I'm just going to make sure that my vertical shift of -1 is going to accommodate going up 3 and down 3. Okay, so those are going to locate my min and max points here. Okay, so I've got pretty much everything I need. I've used my horizontal shift and my period to figure out my quadrant, my vertical shift to find my vertical middle. Now I'm going to use the amplitude to graph. Now be careful with this because now we have to accommodate this negative, which is a vertical flip. So instead of starting at the top, I'm going to start at the bottom. I'm going to go to the middle. There's my first quadrant. I'm going to go to the max. Okay, and then back down to the bottom here. Notice that that is a vertical flip of the original cosine graph.